Hi, hello. In this session, we'll go through lists. A list is an ordered collection of objects. A list is a container which holds comma-separated values between square brackets. For example, let's create a list 1, 4, 5, 3, 2. So there's a list. I have created it with integers. Now let's create another list with string objects. Be equal to hi, hello, bye. So now we have created a list with string objects. I would like to try something different. Now a equal to 1, hi, 4, 5, hello. So lists are not bound to one type only. You can combine multiple types of objects together and create a list. Not only this, list also can contain some complex objects like functions, classes, modules. We will go through them in the later sessions. So these comes under a little advanced. We are not going to cover now. A list can contain any number of objects. There is no limit. It all depends on how much memory our computer have. So list allows duplicate elements. It cannot be unique always. It need not be unique. So it allows duplicate values. Let's say we can create a list with 1, 2, 3, 1, 4, 2. So if you notice here, 1, 2 are duplicate elements. List elements can be accessed using its index. List index always starts with 0 and ends with length minus 1. So it's a similar to string, what we have seen in our previous sessions. Um, you have 0, you have 1, you have length of a minus 1, which returns last element. It is similar to string index, which we have seen in our previous session. The negative indexing also works here, like a of minus 1 gives the last element, a of minus 2, which gives last but 1, a of minus 3. Yeah, so if you notice, the negative indexing works in reverse order like strings. So list slicing also similar to string slicing. We can extract a substring, sorry, we can extract a sublist using list slicing. Now let's define an array 1, 3, 5, 6, 7, 8, 2. Now a equal to this. Now I want to use slicing on this array, sorry, list to 5, right? So now it is started with index 2 has given one element just before 5. Now if I say a 0 to 5, it returns from start to index one element before fifth index. So we can also omit first index. In that case, it considers from starting to till one index before 5. A similar approach where we can ignore the last index. It returns us the sublist which starts at fourth index to till end. Now, what if we omit the complete start and end index? It returns us the entire list. So similarly, what we have seen in string slicing, the negative indexing also works with list slicing as well. A simple example I would say from fifth index minus 1. Minus 1 means last index. It returns 8, right? So also if you notice, list slicing also support stride. That means we can say A1, 5, and the step is 2. So in this case, it try to extract a sublist from index 1 till one element before fifth index with step 2. That means every alternative character will be returned here. So what happens in this case? The list will be reversed. This is again similar to what we have seen in string slicing. One thing we should notice here is, though slicing functionalities are similar in both strings and list, the internal implementations are different. The string slicing always returns the same object, whereas list slicing returns new objects. Please remember this. Now, if you want to test this, let's create a string called test. So now let's check if both are same. Here it is same. The string slicing returning same object. Let's test the same thing with our list. Is A. It's false. The list always returns us the new copy of a list. We can use many Python provided inbuilt functions on list. For example, okay, let me define a list here. 2, 4, 5, 2, 3, 7. Now you can directly say 2 in A. It says true. Now let's search for 100. 100 in A. It's false. It's not there. Similarly, um, 90 in not in A, right? It returns true. Um, 2 not in A, which returns false because the list contains 2. What happens if we use concatenation? A plus 8, 89. It's just adding them. What happens if we use multiplication? A asterisk 2. It just multiplies and adds up those elements based on the multiplication factor. We can use length on the list, which gives length of the list. We can also use min functionality on the list, which gives minimum element in the list. Similarly, use max, which gives max element in the list. A list can be nested. That means a list can contain another list as well. For example, A equal to 1, 2, 3, 2, 3, 4. So here 2, 3 is a list but acting as an element in list called A. Now if I say it returns, it prints data, it prints the list like this. The nesting level can be anything, no limit. So how to access elements from nested list? So for example here, the list is at index 3, right? So now we will access like this. Now we can get like this. Now the nesting level is n. It's all about um, see if you look into here, it's a two-dimensional array. It is acting like the indexing is like accessing elements at two-dimensional array. So if your nesting levels are n, then the way you have to access elements are based on n-dimensional array indexing. Unlike strings, lists are mutable. It allows us to change elements even after its creation. You can change values using its indexing. For example, a equal to 2 comma 3 comma 4. So now I just want to change the element at index 1 to 100. Now when I print, yeah. So negative indexing also supports here. So I want to change the last index with a value 200. So now we change it with negative indexing. Element deletion is also supported. You can use del a of -1. Now print a. The last element has been deleted. Lists also support modifying multiple elements at the same time. This can be achieved using list slicing. Let me create a equal to 1, 2, 3, 7, 8, 9. Now, if I say a from index a from index 2 to 4, add new one, 2, 3, 4, 2, 3, 4. Now let's print a. So now it is added in between indexes 2 to 4. The number of elements inserted need not be equal to the number of elements replaced. Python just grows or shrinks the list as needed. So note that this only works with slicing, not with the direct index based access. Let's see what it is. A is this, right? So now if I want to say A1 with 78, 90, it adds it as a list, not like before what we have seen. So these kind of things can be handled differently. Let's define A. So now if I want to add at index 2, provide both start and end indexing in the slicing same, then you provide your list 78, 90. So it has been added. Now let's go through few list provided inbuilt methods. Append method, one of the method is append method. It adds elements to end of the list. Now a equal to 2, 5, 7, 6, 8. Now a dot append 300. Now 300 has been added at the end. There is another method called extend. Extend method extends a list with the object from another list. For example, a dot extend. I'll give 56, 78. Now let's print a. It has been added. Another list has been added. Insert method. Insert method inserts an object at a given index. As of now, if you notice, append or extend both are not supporting index. If you have anything called index based, let's start using indexing. Let's start using insert method. Insert, you can say I want at 0th index and want 234. Now let's print. It has been added at the first place. So next one is remove method. It deletes the given object from the list. A dot remove, let's say 234. Now if you print, it has been removed the element. Pop method. So pop method also works as a remove, but the only difference is it is index based. Remove method is basically object based. In remove method, we have given element 234, but if we want to use pop, we have to provide on which index we need to delete. So a dot pop, I want it fourth index. It's a 8. It has been deleted. So this is all about lists. Thanks for watching. Please subscribe to the channel.